This next reminder is about derivatives and applications of derivatives. So first of all, you should always apply the derivative rules. So if you have a function that is the product of two functions, you should make sure that when you take that derivative, you apply the product rule. So you would do derivative of the first thing, second thing left alone, plus first thing left alone, derivative of the second thing. And that's product and sum, so the order doesn't matter exactly. If you have a quotient of two functions, then when you take the derivative, you're going to do the quotient rule. And I always say the poem so that I make sure that my signs are correct, but I would do low, d high, minus high, d low, all over the square of what's below. And the reason the poem matters is because this one has subtraction in it, so you want to make sure you subtract in the right order. And then if you have a function that is a composite, you would, let's be consistent about how we write that. So if your function is a composite, you have g of h, so your derivative would be derivative of the mom with the baby left alone times the derivative of the baby. Just to really emphasize, most people don't forget the quotient rule because they can see it's very obviously a quotient. The product rule and the chain rule are sometimes forgotten. It's just you just forget that you do them. So make sure that you are thinking product rule and quotient rule every time you take a derivative and chain rule. The next big topic here is implicit differentiation. Implicit differentiation is what you do when you have x's and y's and you're taking a derivative. So the first thing you do is you take the derivative of both sides of your equation. Every time you take a derivative, you treat y like it's a function using the product and the chain rule. You're taking a derivative with respect to x, so you're treating y differently. You treat x normally because you're taking a derivative with respect to x. And then you plug in numbers if you have numbers so that you're not doing a lot of algebra if you don't have a lot of algebra that you have to do. And then you solve for dx. Sometimes just to make the writing easier, I'll call it m as I'm solving for it so that I don't have to keep writing dy dx. If your answer doesn't match a multiple choice option, try multiplying it by -1 over -1, which doesn't change your answer because you're just multiplying by 1, but it does change your signs. So here's an example. This I'm going to treat like a product because it is x times the function y. So I'm going to take the derivative of x, leave y alone, and then I'm going to leave x alone and take the derivative of y. I'm going to treat this like a chain, so I'm going to do 3 times y squared, leaving the baby alone, and then times the derivative of y. Derivative of x I treat just normally, and then the derivative of 11 would be 0. Like I said, sometimes I like to replace the dy dx with an m. I'm going to factor an m out of both of these two terms, and I'm going to move everything over to the other side. And then I'm going to divide to solve for m. And then it's possible you wouldn't see this as an option because it's equivalent to this answer. So you might see y plus 1 over 3y squared minus x as an option. So don't freak out if you don't see exactly your answer at first. You can usually get there by changing signs unless you made a mistake. The other really powerful thing you can do with derivatives is you can find maximums and minimums using derivatives. The first tool for finding maximums and minimums is the candidates test. The candidates test is ideal if you have a closed interval and if you are trying to find an absolute max or minimum. It is super easy to forget to check the endpoints. So when you do candidates test, and every time you have a closed interval, you do have to check the endpoints. So you're going to check the critical points. Critical points are when f prime equals 0 or when f prime does not exist. So those are the critical points you're going to check, and then you're going to make sure that you also check the endpoints. And when I say check, it means you are comparing y coordinates. The way you get y coordinates is you plug your x coordinate into f of x. So you're not using f prime when you're comparing, you're using f because you want y coordinates. The first derivative test is the one that we usually do a sign chart for, but the sign chart is not the justification. You might be doing a sign chart, you might say that there's a 0 on your derivative at a and b, and maybe your first derivative is positive, and then negative some more. And so the justification would say f of a, which is the y coordinate, is a max because f prime changes from negative to positive. I'm sorry, from positive to negative. If you're talking about the maximum value, that's the y coordinate. Make sure you're clear about that. You can also use the first derivative test if you wanted to talk about an endpoint. So at c, f of c is a minimum because it's an endpoint. And f prime, f prime is negative before it. So that's the first derivative test. This part right here is your work. It's totally cool to have that work there. Your AP reader will not use that as a justification. They will look at it as being there, but they will not give you points for it. So you want to make sure you use the language. Second derivative test. The second derivative test is the one that says that you have, first of all, you have a horizontal tangent line, and then you have concavity. So you might also have that your function is concave up. So that would mean that you have a concave up function and a horizontal tangent line. So that would be a minimum. Or it might be that your function is concave down. And so that would mean that you have a frown shape and a horizontal tangent line. So that would be a maximum. The second derivative test justification is a little bit easier to write. So sometimes it's handy. It's also often necessary for implicit differentiation because it's too hard to talk about a sign change if your x and y coordinates are both changing at the same time. It's also sometimes handy when you have a Taylor polynomial and you're asked whether you have a maximum or minimum, because you can figure out the first and second derivative by analyzing the coefficients and using that to figure out whether your first and second derivative are 0 and then negative and positive. So that's another time when the second derivative test comes in handy. A word of warning about your justification when you're using especially the first derivative test. Make sure that you name the function, and by name the function I mean call it f of x, or call it f prime of x, or call it f double prime of x. So make sure you give it a name. Don't say it, or the derivative, or the graph, or the function. Make sure you're extremely clear about which function you're talking about when you are trying to justify a maximum or a minimum. Another word of warning, finding a maximum or a minimum on your calculator is certainly allowed. They can't stop you, but it is not a justification. So you want to make sure that you're using these calculus justifications for any time you have to talk about a maximum or a minimum. All right, thank you. Bye.